Hey guys, so today I'm going to show you a few examples of how to do metric conversions using dimensional analysis. I'm going to show you the easy way and the hard way. Unfortunately, we have to know the hard way, especially for mole conversions that we'll do a little bit later on this semester. But I want to go through and do a few examples with you guys so that we're all on the same page. And I just feel like me being able to write it out step by step and show it to you would be a little bit better than doing it on the computer, because unfortunately, even though it's wonderful that we are in a virtual environment, sometimes, especially with math, it can be a little bit hard without seeing your teacher do it by hand, so step by step. So let's go ahead and just refresh ourselves. Here we have our units and their conversions. So I'm going to just pull this up, and I'll link a copy of this for you guys as well. So remember, we have our basic unit in the middle, and then we have our prefixes that tell us how many, or relates those units together, right? So just a reminder, each of these steps is a factor of 10. So what I mean by that, so if, like, let's say we have meters in the middle, our basic units, so remember we have our meters, seconds, grams, etc. So we have our basic unit in the middle. So a deci would be a factor of 10, centi would be a factor of 100, and milli would be a factor of 1,000. So in the opposite, in the right-hand direction. Now deca, 10, hecto, 100, kilo, 1,000. Okay, so that's just what each one of these are. So each one increases by a factor of 10. If we go from our basic unit to the left, we're increasing, so we're getting larger. If we go from our basic unit to the right, we are getting smaller. Okay, so when you set up your conversion factors, you're going to need to be able to tell how many of each one is in the base unit. So just so we're all on the same page, each one is a factor of 10. Okay, so let's go ahead and do our first example. So we have 256 centimeters, and we want to know how many meters that is. So how many meters are in 256 centimeters? Well, the first thing we always do is we start with what we know. Okay, so we have 256 centimeters here. Okay, and we want to set up our T-chart. Now I'm going to set up a T-chart in this first one, and then in the second one I'm going to show you how I like to set them up for me. It looks more like a fraction. To me, that's a little bit easier, but you do you, all right? So if you like the T-chart, definitely use the T-chart. Okay, so here's my T-chart. Now, whenever we do a dimensional analysis, we want to relate the units to each other using a conversion factor, okay? So we have to figure out our conversion factor, and we also have to figure out where we want to place our units, okay? The first thing I always do is place my units. The first thing we want to do is look at the units we have in the top of our T-chart, okay? Here we have centimeters. So that means we want to get rid of our centimeters because we're going from our centimeters to our meters. So I'm going to put my centimeters in the bottom on the right-hand side of my T-chart because they're going to eliminate, right? That cancels them out. And I want to put the unit that I want to be left with on the top. Okay, so I know I want meters when I'm done. So I'm going to put that on the top, and then my centimeters that I want to eliminate are going to be on the bottom. Okay. Now we have to relate our two factors together. Okay, so we have to figure out our conversion factor. Now, typically, when you have a base unit, you're going to start with the base unit, right? So one base unit. Now, meters is our base unit, so I'm going to put a 1 with my meter. Okay, there's 1 meter, and that's our base unit. Now, how many centimeters are in a meter? Well, remember, we can look at it as a factor of 10. So our centimeters are here. So our basic unit is here. So we've got 10, 100, right? That means for every 1 meter we have, there are 100 centimeters. Okay, so I'm going to put the 100 with my centimeters. Okay. And now we can just solve. Now this is your conversion factor. This is the factor that relates the two together. So for every 1 meter, there are 100 centimeters. That is your conversion factor. Now that we have it set up, we can go ahead and eliminate our centimeters because those are going to cancel out. And we're going to just do our basic math. Now this is just a fractional problem. Okay, so this is a basic fraction math. So we're going to do 256 times 1 divided by 100. Okay, so see that the 256 and the 1 are in the numerator. The 100 is the denominator, so we multiply across. So 256 times 1, and then divide by 100, because 100 is in the denominator. All right, so then all we have to do is type this into our calculator. And for you guys, your phone calculator should be fine. So we have 256 divided by 100 is 2.56. And of course, in chemistry and any science, we want no naked numbers, ever. Don't ever show me a naked number. We want to make sure we keep our units. So that's 2.56. Okay? So 256 centimeters is 2.56 meters. Now, that's the hard way. That's the dimensional analysis way. We have to know it. The easy way is just using our little chart to move the decimals. So we start with 256 centimeters because this is a whole number. Our decimal is right here behind the 6. So we're going to our chart, find where we start. We're starting at centimeters. And to go from centimeters to meters, we go to the left 2 places. Okay? So again, we're starting at centimeters. We go to the left 2 places. And so therefore we would move our decimal to the left 2 places. So 1, 2. So that would give us 2.56 meters. So it's a lot quicker to do it this way, and I wanted to show it to you just because, I mean, sometimes when you need a basic unit conversion, it's easy just to move the decimals, but you are also responsible for knowing how to do it the mathematical way as well. Okay? So let's do one more example. And then, of course, I'll do some examples with you guys in class as well. All right, so same thing. We're going to do number 6 over here. 86 grams is equal to how many milligrams? Well, let's start with what we know. Now, this time, instead of doing a T-chart, I'm going to show it to you by using just fractions. I like the way with the fractions because I feel like that's a little bit easier to me. But whatever way you like, T-chart or fractions, you're going to get the same thing. So anytime I have what I start with, I always put it over an imaginary 1, just so as a placeholder, so that I can keep my fractions in place and I can keep up with everything. Okay, so instead of setting up a T-chart, I'm just going to set up another fraction, but again, it's the same thing as a T-chart. Now, I know I want to get rid of my grams because I'm converting from grams to milligrams. So the first thing I'm going to do is put my grams in my denominator because I want these two to eliminate, okay, because they're fractional. So if you have a gram on top and a gram on the bottom, they're going to eliminate each other, okay? And I want to end up with my milligrams on top, so I'll put him on top, okay? Now I have to get my conversion factor. So I have to figure out what my conversion factor is for these two. So I have my base unit here, which of course is the gram. Oops, a little bit too far forward. Put it down here. So I have my base unit of 1 for the gram, and we're going to milligrams, right? So we're going to milligrams. Milli is over here at the end, so that's going to be a factor of 10, 100, 1,000. Okay, so there are 1,000 milligrams for every 1 gram. And remember, you always want to keep the numbers together. So if there's 1,000 milligram, the 1,000 goes with the milligram, whether it's on the top or the bottom. So for every 1 gram, there are 1,000 milligrams. Okay, now we can do our math. We know that our grams are going to cancel. So here, this would be 86 times 1,000 milligrams all over 1 times 1. Right? Do you guys see how we're doing this math? This is just fractional math. You multiply across first, and then you divide. Okay? So that would just be, if we type it into our calculator here, I'll show you. I think you guys know how to use a calculator, but just in case, all we would have to do would type in 86 times 1,000, which would give us 86,000. And then 1 times 1, of course, is 1. So that's just 86,000 milligrams. Okay, so that's our answer. That's the dimensional analysis way. We got to know how to do it that way. But if we're doing it the easy way, we start at 86, right? Our decimals behind the 6. We're starting with our grams in the middle because that's our basic unit, and we go to milligrams. So we go 1, 2, 3 over. We went 3 in the right-hand direction, which means you just move your decimal 1, 2, 3 places, which gives you 86,000. Okay? So like I said, the decimal movement for unit conversions, it's a lot easier. It doesn't take as much time. But in terms of dimensional analysis, the math setup, we do have to know how to do it this way. Okay? So we'll do some more examples together in class, but hopefully this was helpful in showing you how to convert. Now, one thing I do want to mention for number 2. Number 2, you have centimeters and millimeters here. These are not base units because meter is your base unit, so you're converting between centimeters and meters. All you have to do is look how many factors you go over because each one is a factor of 10. So if we go from centimeters to millimeters, that's just going to be a factor of 10. That means there's 10 millimeters in every 1 centimeter. So you could treat centimeter as your base unit, and when you set it up, you can put the 1 with the centimeter, and for the millimeter, you can put a 10 because it's a factor of 10. Okay? So I hope that was helpful, but if you guys have any questions, of course, let me know.